You know that old saying, your biggest weakness is your biggest strength? It sounds like something out of a self-help book, right? Well, today we're going to see how that one idea is the actual bedrock of a multi-billion-dollar system. We're diving deep into a super counterintuitive but totally brilliant design choice right at the heart of Bitcoin.
So, let's kick things off with a question that kind of breaks your brain a little, especially when you think about tech. I mean, we always want the next big thing, right? More power, more features, more speed. But what if I told you that for Bitcoin, the real secret sauce to its security is a programming language that was deliberately designed to be, well, weaker? Okay, to really get why that is, we need to first understand what it even means for code to be all-powerful in the first place. And that's where our story really kicks off. All right, the fancy term for this is Turing Completeness. And believe me, in the coding world, it's a big deal. A language that's Turing complete, think Python or JavaScript, is basically a powerhouse. It can solve pretty much any computable problem you can imagine. It's the gold standard. So you'd think that for a massive global financial system, this is exactly what you'd want, right? Maximum power.
Well, here's the twist. When you're talking about a decentralized network like Bitcoin, where you have thousands of computers all over the world that have to agree on everything without any central authority, that kind of ultimate power, yeah, that can be your single biggest weakness.
And this isn't just a theoretical problem. This vulnerability has a name, the infinite loop attack. And it is a total nightmare scenario, the kind of thing that could literally bring the entire Bitcoin network to a grinding halt. So just picture this. A malicious actor, a hacker, crafts a special transaction. On the surface, it looks totally legit. But hidden inside, the code is a digital poison pill. It has just one job, to start running and then to never stop. And here's how that would play out. It's shockingly simple, but devastating. First, the attacker broadcasts this poison pill transaction. Then, some poor unsuspecting node on the network grabs it to start validating it. But because of that hidden code, the script never finishes. It just runs and runs, hogging all the computer's CPU until the node just freezes. It's totally bricked. Now imagine that happening to thousands of nodes all at the same time. The entire network paralyzed.
So how on earth did Bitcoin's creators get around this? Well, it wasn't by building some super advanced firewall. No, their solution was much more elegant. They just fundamentally limited what Bitcoin's code is even allowed to do from the get-go.
And this chart right here says it all. You look at a typical, powerful programming language, and you've got tools for repeating tasks, right? Things called for loops and while loops. But Bitcoin's language, called Bitcoin script, it has no loops at all. It also doesn't have something called recursion, which is another way to make a program repeat itself. Everything in Bitcoin script is designed to do one thing: run once and then stop, period. This gives you a rock-solid guarantee that every single script will always finish, and it'll finish fast. And let me be super clear, this isn't a bug. It's not a mistake. It is probably the most important security feature you've never heard of. By just removing the tools that could create an infinite loop, they made the infinite loop attack completely and utterly impossible. It can't happen by its very design. Okay, so getting rid of infinite loops is a huge part of the puzzle, but it's only half of the solution. There's a second, equally crucial limitation built into Bitcoin's DNA. And it's this idea that to make the system fair and predictable, it has to have a really, really bad memory. In fact, it has to have no memory at all. The technical name for this is stateless verification, and the best way to think about it is like this. Imagine a judge who has to rule on a case, but they have complete amnesia about every single case they've ever seen before. Each transaction is judged in total isolation. The script only knows what's inside that one transaction. That's it. It can't check what happened 5 minutes ago. It can't go online to check the price of something. It knows nothing about the outside world. So what does this do? It creates absolute ironclad predictability. Because there are no outside variables, no history to consider, every single computer on the network looking at the very same transaction is guaranteed, 100% guaranteed, to get the exact same answer. Valid or invalid, the outcome is what we call deterministic. So, okay, we've got these two massive limitations, right? A language that's not allowed to run forever and a system that's not allowed to remember anything. Now, let's see what happens when you put those two ideas together. This is the big payoff. First, you've got Turing Incompleteness. That gives us predictable execution time. You know for sure that every single script is going to finish. No freezing, no crashing. Then you add stateless verification on top of that. This gives you a predictable outcome. You know that every computer in the world will get the exact same answer from that script.
And when you combine predictable time with a predictable outcome, you get the magic ingredient. You get something called deterministic consensus. And that is the secret sauce. It's the ability for this massive global network of people who don't know or trust each other to all agree on one single version of the truth without anyone being in charge.
And this, right here, is why this whole thing is so important. These deliberate weaknesses, these limitations, are the very things that make it possible for anyone, anywhere in the world, to run the Bitcoin software and independently prove for themselves what is true. They're guaranteed to get the same answer as everyone else. This is how you build a system where you don't have to trust anyone. The trust is in the math. It's in the predictable, limited, and transparent code.
So, we've come full circle. Bitcoin's greatest strength is literally born from its intentional weakness. Its security isn't about what it can do, but what it was specifically designed not to do. And that just leaves us with one final thought to chew on. In our world that's just obsessed with more features, more power, where else might we find that the best, most secure solutions actually come from having the wisdom to choose less?